Hello everyone. Today we are going to study about a topic CPU. CPU is the brain of the computer. The CPU mainly consists of two parts: ALU and control unit. ALU performs logical operations and arithmetic operations like addition, subtraction, and comparison. It controls and manages operations inside the CPU. Control unit acts like manager or coordinator. Without the control unit, the processor would not know which instruction to execute, when to execute, where the data is located. So, in simple words, control unit controls the flow of data and instruction in the computer system. Now, what is the control unit? Control unit is a component of CPU that controls the flow of data between processor, memory, and input and output devices. It decodes the instructions stored in the memory and it generates control signals that allows CPU to execute instructions. Control unit that decodes the instructions which means to it understand what operation is required, where the operations are located, how the operation should be executed. After decoding the instruction, the control unit generates control signals. Now we will study about the functions of control unit. So there are two main functions. So first function is sequencing, and the second function is execution. Now we will study about sequencing. Sequencing means executing operations in the correct order. When a program runs, it has many operations. Each instruction goes through phases like there is fetch, there is decode, there is a phase called execute, and sometimes interrupt. Each phase consists of micro operations. Now let us understand how a program runs in a computer. Basically, a program is a sequence of instructions, and each instruction goes through an instruction cycle. Instruction cycle consists of these phases: fetch, decode, execute, and sometimes interrupt. And each phase involves micro operations. Now let us understand this with an example. During fetch phase, instruction address is sent to memory. Now instruction is fetched and instruction is stored in IR. During decode phase, control unit decodes the instruction, and during execution phase, the required operation is executed. All these operations are controlled by the control unit. General model of control unit. The control unit receives 4 types of inputs. Now let us study about the inputs to control unit. First is clock signal. Second is instruction register IR. Third is flags, and fourth is control signals from system bus. from system bus. Clock signal. The clock signal keeps the timing of the CPU. So each clock pulse triggers one micro operation or a set of micro operations. Instruction register. What does instruction register stores? Instruction register stores the current instruction. This stores the current instruction. Instruction contains opcode, which tells about the operation which needs to be performed, addressing mode, and operand address. Flags represent status of the processor. For example, 0 flag Z, carry flag, sign flag, overflow flag. These flags help the control unit to decide what to do next. Now we have outputs of control unit. The control unit generates control signals. These signals go to two places. See, control unit generates two signals. Generates control signals, and these signals go to two places inside the CPU and control bus. Go to two places. Where they go? They go inside CPU and control bus. Now there are two types of control unit. Control unit has how many types? It has two types. Hardwired control unit, and second one is microprogrammed control unit, and this is hardwired control unit. Now let us move on to hardwired control unit. Hardwired control unit implemented. This is implemented by using hardware. This is implemented by using hardware circuits. It uses this hardwired control unit. These uses logic gates. Uses logic gates, flip-flops, decoders, encoders, digital circuits. The control signals are generated using combinational logic circuits. That is why they are called hardwired control unit. Now let us discuss its block diagram. So I have written before before that, I have made this diagram beforehand. So it has main components like instruction register, instruction decoder, timing generator, sequence sequence counter, and control logic gates. So first, let's study how it works. Like so, instruction is fetched from the memory. And it is stored in the instruction register. When it is stored in the instruction register, here it is stored, and the now the instruction decoder. This instruction decoder decodes the opcode. Instruction decoder. It has three components. Instruction has three components: opcode. Here we have told you before that it has three blocks. So it decodes the opcode, and then the timing generator. This timing generator generates it produces timing signals like T0, T1, T2, T3. Based on the instruction and timing signals, the control unit generates control signals. These signals perform the required operation. After completing execution, the system resets and moves to the next instruction. Now let us come to advantages of hardwired control unit. So hardwired control unit, it is very fast, and it is like simple for small instruction sets, direct, and it shows that hardware implementation. Now let us come on to the disadvantages. It is not flexible, it is difficult to modify, and it is very costly. Hardwired control units are commonly used in RISC processors. These are used now. Here we will like this use cases. It is used in RISC processors. Now let us come on to microprogrammed. Now let us come on to microprogrammed control unit. Before that, we will study about let's study about microprogrammed control units. It is basically implemented by using programming instead of hardware circuits. We have studied that here we have studied that hardware control unit is implemented by using hardware circuits, but it is not in the same as in microprogrammed control unit. It uses it uses programming instead of hardware circuits. Here the control signals are stored in memory. And this memory is called control memory. There are some terms which I would like to tell you. Control memory, and control memory is the memory that stores microprograms, usually implemented using ROM. Microprogram is a sequence of micro instruction. A micro instruction specifies one or more micro operations. Control word, a binary word containing control signals. Architecture of microprogrammed control unit. Now let's come on to the architecture. Architecture of microprogrammed control unit. Architecture of microprogrammed control unit. So its components are microprogram sequencer. Its first main component is microprogram sequencer. Its second component is control address register, CAR. Third component is control memory. Fourth component is control data register. Control data register. Fifth is decoder. Now let's come on to the diagram and block diagram and working of microprogram control units. So the microprogram sequencer generates the address of the next micro instruction. The address is stored in the CAR. Control address stored in the CAR. This is the microprogram sequencer, and it stores the address of the next address generator, and the address is stored in the control address register, CAR. The micro instruction is fetched from the control memory. This is the control memory. Micro instruction is fetched from this control memory, which also is called ROM, and it is stored in the control data register, CDR. The control word is decoded by the decoder. Control signals are generated by the CPU for the CPU operations. The sequencer generates the next address. Here the control signals with the CPU, and the next address, this next address information is then stored by the microprogram sequencer. This process continues. This whole program diagram continues until the instruction is completed. Now we will study about the advantages of microprogrammed control unit. So let us come on to the next page. Here we will write about the advantages. Advantages of microprogrammed control unit. Advantages of microprogrammed control unit. First one is it is flexible. Second one is it is easy to modify. Third one is easy to add new instruction. Fourth one is suitable for complex instructions. Suitable for complex instruction. Suitable for complex instruction. And it is used in it is also kind of advantage. We cannot call it as advantages. It is we can call it is a use case of microprogram control unit. It is used in CISC processors. Now let's come on to the disadvantages of microprogrammed microprogrammed control unit. So the first disadvantage is it is slower as when compared to hardwired control unit. Slower as compared to hardwired control unit. It requires extra memory for control storage. Requires extra memory for control storage. Yeah. Now, as we have studied both microprogrammed and hardwired control unit. Now let's come on to the differences. What are the differences, so that everything will be clear in your head? So we will make a line, and here we will write the hardwired control unit, and here we will write microprogrammed control unit. First one, the difference we will talk about is about the speed. Here we can write the basis of the difference. We can write on the basis of speed. Speed किसकी fast होगी? The speed is faster here in hardwired control unit, and it is slower in microprogrammed control unit. Let's come on to the second difference on the basis of implementation, how they are implemented. Okay. How they are implemented. Hardwired control units are implemented by hardware circuits, and microprogrammed control units are implemented using programming. Flexibility. Let's come on to the third difference, which is flexibility. Hardwired control unit, they are not flexible, and microprogrammed control units are flexible. The fourth basis of differentiation between them is modification. It is difficult. Hardwired control unit are difficult to modify, whereas microprogrammed control units are easy to modify. The fifth basis of differentiation is instruction set. Here the instruction set is small, and in microprogrammed control unit the instruction set is large. Use cases. Let's come on to use cases. It is used in RISC processors, and it is used in CISC processors. So we have studied both. So today we have studied what is control unit, functions of control unit, inputs and outputs of control unit, hardwired control unit, and microprogrammed control unit, and differences between them. So the control unit plays a very important role because it controls the entire execution process inside the CPU. So this is all for this assignment. Thank you. Have a good day.